Okay, any other questions, anyone? Don't be shy, because otherwise this is going to be really boring. And I could have just podcasted this, which is, I don't know, which is okay, but it's probably not as fun as this for me. Sorry? Two from that same section there? From the practice section or from the more magnificent mole problems? The mole problem section? Okay. Okay. Sorry, I did. This sounds not great. So, okay. Yeah, just give me 1 second here. I got this. I'm going to do something. Scroll up. Oh, yeah, there we go. I got this. Bye-bye. All right. Look at me figuring stuff out, eh? Good thing I'm only 22 because I'm still, in touch with technology and stuff. You can laugh. Okay, we're not laughing today. Okay, great. All right. All right. Any questions from the practice part yet? Still just the practice section. Any practice questions there? Number 4. Okay, I'll get to 2 in a bit here. How many atoms? That one in 4.54 grams of zinc. Okay. So with that one there, of course, again, really important. It says how many atoms. So we're looking for, my pen turned off. There we go. We're looking for the atoms, of course, which is, the far right kind of thing. Remember we had this yesterday. We have moles here, and of course we have mass here. Yeah. In this case here, we have what, 4.54 grams of zinc, so that'd be over here. So we're starting here. We need to get to there and to there, so we're going to use our formulas like we did yesterday, mass and molar mass, or 4.54 grams of zinc. You know what I don't have is a periodic table today, but that's okay. 65.41 grams per mole. And you know what I don't have, though, is a calculator. But I got one right here eventually. This is stuff I didn't think about, to be honest. All right, 4.54 divided by 65.41. Oopsies. 4.54. There we go. So that is a 0.0694-ish. And that would be in moles, yes. And then, of course, we're going to take that 0.0694-ish and multiply it by, sorry, that's moles there. And we're going to multiply it by 1 mole, 6.02 times 10 to the 23. And in this case, we're talking about atoms. So we're going to put atoms there, yeah? So we're going to take that number and multiply it by 6.02 times 10. Let's see here. How do I do this now? I don't have the right calculator. I got to go find my other one. To the, I don't know. So does that give you, let's see. Where'd that question go? Yeah, 4.178. Yeah. 178 times 10 to the 22, I guess. Yeah. That sounds about right. Atoms. And then, let's see, significant digits, I guess, in this question are what? I'd say probably 3. So 4.18 probably would be my best answer there, times 10 to the 22 atoms. Good? Okay. Any other questions from the practice part there? Okay. What about more magnificent mole problems? Is that the number 2 there, one that you want me to do? Yes? Okay. Let's scroll this up here. Okay. Number 2. What is the mass of 1.27 times 10 to the negative 2 moles of aluminum sulfide? Okay. Well, let's kind of look here. I guess the first thing is, again, we have what is the mass. So we're looking for the mass. Okay. We have 1.27 times 10 to the negative 2 moles. That would be N, of course. Yes. And we know it's aluminum sulfide, and aluminum sulfide, yeah, aluminum sulfide would look a little something like this, yes. 3 plus, 2 minus, this little swap and drop there, so 2 and 3 would be like that, okay? Good. We can get the molar mass from that, which I'll do here right away, but let's see, 2 times, aluminum's 26.98. Does that sound right, somebody? Okay. And 3 sulfurs, I think I know that is 32.07. So that's 150.17 grams per mole. Yeah. Somebody agree with that? Good. Okay. So that gives me big M. Yes. We're looking for M and we know N, right? So in this case here, we're just using this formula here, mass and molar mass, right? So that's all we need to do for this one. We need to solve for the mass, of course. So we're going to cross multiply or multiply both sides by big M, right? Whatever you want to do. But we need to come up with this formula here. And then we're going to put in our moles here, 1.27 times 10 to the negative 2 moles. And we're going to multiply that by 150.17 grams per mole. Okay, and then we multiply those two together. Again, hopefully we don't have the wrong answer here. Let's see, 0.0, let's just see here. What is that? Oopsies. I need a different calculator, I know that. Times 150.17. Okay, I get 1.907, and that would be grams, because remember that moles and that moles cancels. So what is that? Let's see, what's the answer here? Or significant digits, I guess, is the other thing. I'd say we need 3 significant digits for that 1.27 part in the question. So I guess that'd be 1.91 grams there should be the answer there, which is what it is there. So, okay. Good. Okay. Any other questions from that section there? 1, 2, 3, or 4? Anyone else? I guess we did 2, but anything else? I see you. Yeah. Oh, I thought you had a question. I got excited there for a second. All right. Any other questions? Yes, no? Okay, we're going to move on then. I'm going to get this out of the way here. I wonder if there's a better way to do this. I'll figure it out. All right, let's find, I know this is a while ago, but I said we were going to give you an option yesterday and you wanted to wait to go over your quiz here. So let's find your quizzes there from a while ago. It's quiz 6, of course. I'm going to drink some coffee. You find your quiz 6. We'll go over that. If you don't have it back, I know Georgia doesn't. I don't know who else doesn't. I think that's it. And I know, Sydney, you need to write it. We'll figure out a time sometime. I'm not sure when, but we'll figure out something there. I got to give you different questions probably anyway, because I'm going to give you the answers to these. So, all right. Are we all good? We're ready to go? So quiz 6, we had all these reaction types. Yeah. Yeah, I think, and if you want more practice with this, I guess just talk to me at some point, or even just shoot me an email or whatever, and I can send you something if you want for a little more practice. And I guess same thing, we have 4 days off here. So if you want to get a little more practice or whatever, if you feel like you need more, most of you did pretty well. So I'm not too worried. Sometimes I'm a little bit more worried, but you actually did okay on this. So, but if you want more practice, shoot me an email and I'll try and send you something back here, a little more practice or whatever. Okay. So for question, are we good? We're ready to go? I don't like this as much. This is not, I don't like this. All right. This is not the same, because usually I sit in the chair and we didn't do that, and I don't like that. And I ask you how. Yeah. 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 Usually we have a little chat about how is everyone feeling today, et cetera, et cetera. Nobody says anything. I crack one joke, and then nobody laughs, and then, yeah. All right. Anyway, all right, here we go. 1A. So we have a reaction type there. We have C2H4. I guess I got to write this down here. C2H4. and oxygen. I'm going to skip the states for right now because I don't, they're either there or they're not. I'm not sure, but yeah, I guess they are there, but you already have the states there. So this is, of course, a combustion reaction, right? We have a fuel here plus our oxygen. So we're going to put down combustion. Balancing wise, again, I'd say, kind of start left to right. Start with the C's here. We got two C's here. So I want to make sure I have two here. I'm going to put the two there. Okay. We have four hydrogens. So again, 2 times 2 is 4 hydrogens right there. So that's 4 oxygens and 2 more, that's 6 oxygens. So I'm going to put a 3 here to make that 3 times 2 is 6. Okay. And again, that's a combustion reaction. Okay. Again, if you have any questions, you just got to maybe just say something because I'm not probably watching the video thing there. I'm watching my iPad here. So next one here is just AU. AU, come back here with my gold watch. Get it? Okay, that's great. AU, come back here with my gold watch. No way. AU is gold. Yeah. And I'm saying, AU, come back here. I got to explain these jokes sometimes because they're pretty high level. And sometimes they just don't quite get them because they don't laugh. Right, Georgia? Yeah. You're not laughing for some reason. I'm not sure why. No, don't be sorry. Just laugh. All right. And lead. PB, what do we got? CL4 here and AU. All right. Again, this would be what kind of reaction here? Somebody tell me. Single, yeah. So single, and we know that because we have a metal here, right? And the metal, of course, is going to switch with the metal here, yes, and that's what's going on here. So we have, everything's balanced. It's except for this part here, right? So we got the old switcheroo, or the old, lowest common multiple, as I guess the math people would want us to say. So I'm going to put a 4 there and 3 there to make 12 on both sides. I'll put a 4 there and a 3 there. Okay, is that good? Give me a nod. Okay, all right, next one. We got some rubidium and some nitrogen. And again, we're going to get rubidium nitride. Okay, don't forget when we do these N, okay, don't forget the nitrides. Then there's nitrite, which is a polyatomic ion, and nitrate. Yes, so just remember that. Okay, Haley? Okay, all right. This is, of course, formation, we're going to call this formation. And again, I'd probably go left to right. Having said that, my issue is going to be right here kind of thing, yes? So, as you get more and more practice with these, we're going to realize, okay, well, I probably going to need to put a 2 there to get 2 ends. So I go with 2 ends. And then I'm going to have 6 RBs. So I'm going to put a 6 there, okay, altogether. So it should look like that. And then what do we got? CS2. Yeah, an S. And that is, of course, in this case, decomp, yeah? So we have some cesium sulfide, and that's going to give me cesium and sulfur. And anytime you're balancing sulfurs or phosphoruses, you want to start with those first, yes? Because obviously 8, that's going to be a lot. So if I got 8 here, I'm going to put an 8 here to make 8 sulfurs. And then I got 16 of these cesiums, and so I'm going to put 16 there. Okay, good? Questions, anyone? All good? Okay, let's scroll on to the next part here. Here we go. You have to write out this reaction with states. So we got some chromium metal here. So chromium metal is a solid, yes? Okay. I know there's more than one person who did this. There's 3 of you, in fact, and I pointed that out to you, other 2, and I talked to you, the other person, yesterday. But the other 2, okay, this is, stop doing this, okay? Don't do this. It's not chromium 3. There's no 3 there. That's the charge, okay? That's if you combine it with a metal and a non-metal, we're going to use the chromium 3. We don't put a 3 down here because Chromium is a metal. It comes by itself. Okay, so just chromium, that's it. So the metals are just chromium, K, potassium, cesium, one cesium, magnesium, just magnesium. Okay. Um, in this case here, we're reacting with oxygen gas. We are going to put a 2 here because remember in the top right of your periodic table, we have that list of molecular elements, right? I have no bright or clever friends, people stupid, right? Or Hofbrinkel. So we're going to combine these two together. And that's going to give me what here? Chromium oxide, I think it says, right? Chromium 3 oxide. Now, this is where we're going to use the two charges here. We're going to use these two here, of course, and we're going to swap and drop. This is where the chromium 3 would come from, yes? So I'm going to say, okay, well, that's chromium 3 oxygen, or oxide, sorry, like that, okay? Balancing, let's see. Again, chromium's probably not going to start with chromium in this case. I'm going to probably start here because I got 3 there and 2 there. So again, little switcheroo thing there, 6 and 6. And then 4 chromiums is what I want to have there. Okay, good. Questions, anyone? All right. What's that? Oh, yeah, sorry, states, yeah. Gas here. Now, yeah, thanks for doing that, Chris. So gas there, solid there. I think it says that, I think. And then it says produce solid chromium 3 oxide. So we're going to put a solid there for this one here. Okay. Please remind me when we get to the later on, we're going to talk about that again here. When we get to a little bit farther down the road here on the back side, I think it is. Okay. We'll talk a little bit more about that, but we should put solid there. It says solid, so we're going to put solid. Okay. All right. Yeah. That's what I'm going to talk about coming up here. So maybe we'll just be patient here coming up because I think there's a couple coming here right away. The answer is yes and no. If it's a formation reaction, they should always form solids. Okay. Or decomp, they're always going to be a solid ionic compound because ionic compounds, of course, hold together really well. If you're doing single or double replacement reactions, they will probably be aqueous. But again, with the double one, we have to make sure that we check the solubility chart too, right? So in that case, just like when we went to the lab, and I think the very first one you guys did, you mixed together and it turned that red, yes? That solid red. That's a precipitate, so that's the solid, but there is an aqueous solution there, okay, as well. And in fact, we should probably go back because it settled out really well actually, and I probably should show you that at some point. So hopefully we'll do that on Wednesday, I'm hoping. So maybe tomorrow, I don't know, we'll see. All right, what's next here? CF2 and I2. We don't do a lot of these, so I don't know, but we don't do a lot of these. However, again, when you look at these two here, this is a non-metal now, and we're reacting with an ionic compound, so it needs to switch with this non-metal here. So these two need to switch places. So we're going to get F2 by itself. Again, it doesn't matter which order. So we're going to be switching, sorry, those two there, yes. It doesn't matter which order you put these in, of course. And then calcium and iodide. Now, I know that this says right here I2. I get that. However, when we combine these two together now, so Ca and I, we have to make sure we're using charges here, yes? So don't think just because, well, this is I2, that I'm going to switch that into I2 here. It really comes from a 2 plus and a 1 minus, which does happen to be a 2 there, yes? Okay. Again, I think we started with aqueous here. So we're going to start with aqueous, or we're going to have aqueous over here as well. This is a gas, of course, fluorine. We're going to look that up on the periodic table, and that's a nonmetal, so that should be a gas. All right. Balancing, I think we're good, yeah? And of course, this would be a single replacement again. Okay. Single replacement. Good? Okay. This one here, RBI. That's a solid, of course, ionic compound, and we're going to get some rubidium. Now, an I has to be by itself here. So when we write I by itself, again, it's I2, H2, N2, O2, Cl2, etc. So that's what we're going to end up with there. I would probably put a 2 here and then 2 there, and I would say that this is, of course, decomp. Good? Okay, questions, anyone? I'm going to scooch that up here. Okay. C3H6 and oxygen. Well, this is combustion. I'm not going to write that down, but just so you know, this is combustion. And again, we're going to get some combustion reactions. For us, we only get carbon dioxide gas and water gas. Yes? Okay. And let's see here. Again, you maybe picked up on the pattern here, but there's 3 carbons there. I'm going to put 3 there. There's 6 hydrogens, so 3 times 2 is 6 hydrogens. Okay. The problem with this, of course, is what's going to happen is I'm going to have 6 O's here and 3. So that's a total of 9 oxygens here. And of course, to balance this, I could put 4.5 there. I mean, it is balanced. Of course, we can't leave it like that. So this is where we kind of run into this issue where, well, 4.5 is okay, but we probably should go back and double everything, yes? So I'm going to put a 2 here. I'm going to put, it was 4.5, so that's 9 now. I'm going to, I could probably, it's going to get pretty messy if I don't erase it. So 6, and this would be 6 as well. Yeah. That way you get 6 times 2 is 12, and 6 is 18. Yes? Good? Questions, anyone? So 2966 for that one there. Next, what do we got here? Okay, so this is going to be a double replacement reaction. We got ionic compound. What do we got here? Copper 2 perchlorate, that is aqueous, and lithium phosphate, 1 plus 3 minus, aqueous. Okay. And of course, in this case, the metals switch places, right? 2 ionic compounds. Notice they're both aqueous. When we switch them, we're going to get some lithium perchlorate and copper. And again, we're using copper 2. So we started with copper 2. We end up with copper 2 phosphate. So we're going to have to put brackets here, 2, and then phosphate's a 3 minus, so that's going to go there. And now this is where you're going to look up the states. Yes. This one's probably the easier one to find. That's the solid. Okay. This is on the back of the periodic table. Yes. Okay. So find phosphate across the top, PO43 minus across the top on your solubility chart, and then find copper 2, and it should be in the bottom there in that section. And this will be aqueous here. Okay. Balancing. Let's see. Well, right here, I'd probably start in this case. I'm going to put a 3 in front of here for 3 coppers, 3 coppers. I'm going to have 6 of these perchlorates, right? 3 times 2, 6. So I need to put a 6 here to get 6 of these perchlorates right here. I got 6 lithiums. 2 times 3 is 6 lithiums. And then I got 2 phosphates, and I got 2 phosphates. So we should be good. Okay. Good. Any questions, anyone? We're almost there. I'll stop talking soon here. All right, let's scooch that up. And what do we got? Zinc. Okay. I would say this is pretty typical of a single replacement reaction here. This would be one that would be good to know, of course, on a test kind of thing. Pretty straightforward. Well, no, I don't know about pretty straightforward, but it's probably more common than the other ones that we've done so far. So these 2 metals need to switch places. So we're going to get some Fe and some zinc. And again, don't forget, we now need to go with, when we're combining these together, we go with charges. So this is a 2 plus and a 1 minus, or basically here we're going to do a little bit of this ZnBr2. Oops, Br2. That'll be aqueous again, because again, we need to keep this in a solution here. So balancing, of course, everything looks good except the BRs. We're going to do the old switcheroo, 3 and 2, or lowest common multiple. We'll put a 2 for the Fe's and then a 3 for the zinc, and we should be good. Okay? Questions? All right. Moving up. And next. Now, here's, if you guys got these, okay, and I know there's a few little mistakes here and there, but these are the tough ones, right? This is where we're not given anything, and we just kind of tell you, hey, this is what we're going to react together, so it's kind of up to you to come up with the products. So if we get these, we're probably pretty darn good. Calcium nitrate solution. So calcium nitrate. Calcium nitrate is calcium is a 2+, nitrate's a 1- solution, so we'll put AQ here. And sodium phosphate, 1+, 3-, yes. And we will get, as a result, metal switch places, so sodium nitrate and calcium phosphate. And calcium is a 2+, and phosphate's a 3-, so the old switcheroo there. This is where you'll have to make sure, okay, that you look on the back of the periodic table and find out what the states are here, yes? So this should be aqueous. Oh, that doesn't look anything like aqueous. Solid, okay? And then we should be good there, okay? And again, if you have any questions about that, I can find that and we can talk about that too. But then balancing, let's see here. Well, let's go 3 here, calciums, 3 calciums, 6 nitrates, 6 nitrates, 6 NAs, so 2 times 3 is 6 NAs, and 2 phosphates and 2 phosphates. And in a double replacement reaction like this, chances are the last ion, that polyatomic ion or whatever you're doing last, should already be balanced. Because if it's not, then that's going to create some problems for us. So just keep that in mind. All right. Next, we're almost done. What do we got next? Okay, here we go. So this is this isn't the one I was thinking of. That's okay. But solid chromium and calcium nitrate. Okay. Again, switch metals. This is single replacement. Okay. So we're going to get some calcium by itself. That'll now be my solid, right? We saw this with the aluminum and the copper 2 chloride, if you remember from the lab. The aluminum, okay, well, we put that in there, and then we got those chunky things falling off, and that was the copper, of course, where they switch electrons, yeah. And chromium now goes in part of this, but chromium's most common charge is 3, yes? So chromium 3+ and nitrate 1-. Aqueous. And of course, again, we're going to start with here 2, 3, 3, and 2, I believe, yes. This is going to be the issue right here. We got 6 nitrates and 6 nitrates. Yeah? Okay. Questions, anyone? All right, sure. Okay. And this is the one I was thinking of here. Okay, and again, we got some reaction with chromium. Now, we didn't tell you the states on these, and that's okay because we can look these up on the periodic table, right? So if you look over to your right there, chromium, of course, is a metal, so we should have a solid state here. Chlorine is a gas. If it comes in 2s, don't forget, because it's one of those molecular elements, but it is a gas. And when I go to combine these two together, this is formation, of course, metal plus non-metal. We're going to use chromium chloride and, oops, what is that? Chromium chloride, and we have to use the most common charge of chromium, which again is the 3. So 3 + 1-, swap and drop. Now, this is where I took off. If a few people had questions about this or not sure, and I know this is Chris's question here probably, we need to put solid here, okay? We're not using any water to do this. We are simply combining a metal and a gas. Yeah, we're probably going to have to melt this down in order to combine these together, possibly. But when this is all said and done, when ionic compounds are formed, they form solids. if we start with an ionic compound, we want to break it into elements, decomposition, it's a solid. Okay. Just remember, molecular compounds are different. Those are a little trickier. We don't always know the states for those. Okay, so we do want to have a solid here, and that was in the notes, by the way, as well. So we're going to do a little switcheroo here: 3, 2, and then 2. Okay, and we want to have that again. For 3 of you people in class here, I think you know who you are. I said don't do this anymore. Remember, chromium is just a metal by itself, right? There's no chromium-3 there or anything like that. We only use the charge chromium-3 when we're combining it with the ionic compound. If you stop doing that, perfect. You'll be 100% guaranteed. And last, finally, C3H8 and oxygen. Okay. Again, C3H8. It did not say the state of this. This is propane. Reminds me of a song. No, never mind. We're not going to laugh today, okay? Propane is a gas, but I didn't put that on there, so just leave it. Okay, that's fine. You don't need to know that. Again, it's a molecular compound. Molecular compounds are tricky. They can be solids, liquids, or gases. Depends on a variety of factors. This we do know is a gas, oxygen, so we probably should put that there. And definitely we should have gas here and gas here. Okay. All right, so make sure those 2 are gases. Balancing these, I think we're okay if we just go ahead and balance this. So that's 3 carbons, 3 carbons, 4 times 2, 8 hydrogens. So that's what, 6 and 4 is 10. So we're going to put a 5 there. Good? Questions, anyone? Was that too quick? Want me to do that again, anyone? Yes, no? Okay. All right. Okay. So that's your quiz there. Again, if you're not sure or if you think you deserve more marks, you probably don't because I'm perfect. So or just come see me on whenever I get back here. Our daughter's actually a little bit worse today, so I'm not sure what that means. That's not what I really was hoping for. I actually was hoping that she's going to go back to school tomorrow, but that's apparently probably not going to happen. So anyway, good. Let me just stop. I think I recorded this. I think I did. I don't know.